Here we are discussing what is the operating point of the following BJT circuit. Since we are interested in finding out the DC operating point means DC analysis. We have to perform DC analysis of this circuit. So we will first plot DC equivalent circuit of this diagram, which says it is plus 10 volt, it's 1k RC, the collector resistance is 1k. We will ground the AC, and this is the emitter resistance, which is 2.5k, and the emitter we have applied a battery of 10 volts. Here it is written minus 10, so we have attached negative terminal of this battery with the other end of the emitter resistance. Next, we have to apply KVL at base emitter terminal of this circuit. For this, we can use this trick, that this is ground, and then we have base emitter terminal, and the voltage drop across base emitter terminal is 0.7 volts. The collector current and emitter current we assume are almost equal. So from 2.5k, the current which is flowing is IC, and this terminal is connected with 10 volt supply, and we connect it to ground, and then we apply KVL at this loop. So if we apply KVL here, we can plus 0.7, because this arrowhead strikes at the positive terminal of this voltage. We write it plus 7, then plus 2.5 kilo ohm into IC. So we assume that IC is in milliampere, so that kilo ohm and milliampere multiplied will become volt, and it is already in volts. Minus 10 volts is equal to 0. So if we simplify this equation, IC would come out to be 9.3 divided by 2.5k ohm volt. So IC would be 3.7 milliamperes. So collector current, which is flowing through this 1k ohm and 2.5k, I would be approximately equal to IC. Though we know that IC is alpha I, it means I will be a bit larger than IC, because IE is IC plus IB, if you remember. But here we are assuming that it is almost equal. It does not make much difference. IC is 3.7 milliampere. Next, we will evaluate what is the value of our collector to emitter voltage. For this, we will apply a KVL at collector to emitter loop. For this, we will first, this is the collector to emitter loop. How we have designed this loop? Because our collector terminal, this terminal, not collector terminal, this is the collector terminal. So collector terminal is first connected to 1k resistor, and the other end of the 1k resistor is connected to plus 10 voltage power supply. So it is the other end of the power supply is grounded. And next we have VCE. So plus minus, we are assuming that VC is positive, plus minus VC. There is 2.5k resistor. The other end of 2.5k resistor is connected with ground. Now we will apply, because this from both 1K and 2.5K, we are assuming that IC current is flowing. So in this loop, we are assuming that IC current is flowing. So next we will apply KVL. KVL, we have seen this arrowhead strikes at the negative terminal of this battery. So we have written minus 10 volts. Then 1K into IC we have evaluated, we'll write its value later, plus VCE which we want to evaluate, 2.5K into IC minus 10, here we have written minus because again the arrowhead is hitting negative terminal of this battery and the other end of the battery is grounded. We have seen that since we have traveled a whole loop, it will be equal to 0, voltage difference between these 2 points will be 0. Now we will put IC in milliampere as 3.7. So by putting value of IC as 3.7 milliampere, it is 1K, so it will become 3.7 volts. And once we solve this plus VC, everything we solve, it is giving us 10.5, around 10.5 volts. So this is how we do DC analysis of such circuits.